You are watching the 9.6 lesson video on residuals. Now, in order to see residual plots in action, it's really important to just see a bunch of examples, but bottom line is a residual plot is something that we are going to use to tell us whether or not the model that we pick is a good model or a bad model. So like if I use a line to model a bunch of points, it might be a great fit or it might be a terrible fit. And our residual plot is going to tell us what is a good fit and what isn't. So in exercise 1, it looks like we have a skydiver jumping out of an airplane, and they recorded the time versus time and speed every couple of seconds. The first thing that I want everyone to change here is in B, well, I guess in A it says the graph of the data and the line of best fit are actually shown. So we don't have to do that, but it says find the equation for the line of best fit for this data, round both coefficients to the nearest, change that tenth to whole number. Okay, so we can see that our line of best fit is already on there. Rounding it to the nearest whole number, we will get 6x plus 13. Y equals that, because it's an equation. Now, if we look at C, it says just by looking at the data points, do you think that line, do you think the linear model is a good or a bad fit? Well, I don't know about you guys, but this looks like more of a curved line to me, a curved function that I would want to use. So I kind of think that this line is a bad fit because the points follow a curve, not a straight line. Okay, so B or D now says graph the line of best fit. So we're going to be graphing the line of best fit on the graph page on our calculator, which I have here. So 6x plus 13. And then what we want to do is put the predicted. So if we were using this line to make a prediction for every single time from 0 and so on, 2, 4, 6, 8, 10, 12, 14, 75, 39, it doesn't matter, we would use this line that we said. So what we're going to do is look at the table and fill in all those values. So 13, 25, I'm just going to put in all those. So 0, 13, 2, 25, 4, 37, and so on and so forth. So let's do that with all these. What is 6? 6 is 49, 8, 61, 10, 73, and what is 12? 12 is 85. Okay, so what we're going to do next now is calculate the residual right here. And that's going to be the difference between the actual and the predicted. So let's subtract 0 minus 13. So we're subtracting those two, and we get negative 13. We subtract those two, we get 0. Let's do this for the rest of the table. So as you can see, I just subtracted that minus that, that minus that, 68 minus 61, 72 minus 73. And we got our residuals, which all happen to be either positive or negative numbers. Then what we do is we are graphing the residual plot of this data. So the way I guess that I describe this is the line of best fit actually becomes the x-axis. And what we're trying to do is we're trying to measure this distance here, this distance there. Let me scooch up again. That distance. So how far away the actual is from the predicted. That one would be way up there. So you can see that it's not exact, and we're plotting all of those points. So our first one would be 0, negative 13. We're going to do that with all of them. 2 is 25. 4 is 9. So what we're doing here is we're graphing, this is our x, and this is our residual and x. 6 is 11. 8 is 7. Oops, that didn't work out for me. There we go. 8 is 7. 10 is -1. And then 12, uh-oh, we ran out of that. That's -11. It's like somewhere over here. Does this residual plot show a pattern? Sure does. It almost looks like a parabola. So the answer is yes. So what can we conclude from this? Well, we said this was a bad fit because the points follow a curve. So we don't really like a line. We would have much rather have seen a curve. So then when we graph the residual plot, it made a pattern. So what we know now is if a residual plot shows a pattern, the model was not a good fit for the data. So if they didn't give us any of this information up here, they didn't give us that graph or any of this, and they just told us this right here, the residuals and the time, we could plot it, look at it, and say whatever model you used, it was bad. We were lucky that they gave us something to help us visualize on this question. Not always like that. Let's go on to exercise 2. Okay, so it says for both graph A and B, do you think the line of best fit shows the line of best fit shown models the data well, and then determine if the residual plot would show a pattern or not. Okay, this is pretty easy then. So does this model the data well? What do you guys think? Does that line look like it fits it well? I think no. Should be a curve, right? So graph B, yes, that looks so much better, right? You can see the curve just going through those points nicely. So is the residual plot going to have a pattern if it does not model the data well? And the answer, which is kind of confusing, is yes. With residual plots, we like to see a scattered snowstorm of points. We do not want to see a pattern. So a residual plot of a bad fit will show a pattern. A residual plot of a good fit will not show a pattern. Okay, so let's see down below here in exercise 3. It says after performing an analysis of a set of data, Jackie examines a scatter plot of the residual values, and it says which scatter plot indicates the best linear fit for the data, and we need to explain. Well, if I look at all 3 of these, 2 of them have a pattern. 3 of them have a pattern. 1, 3, and 4. 3 kind of like goes like this. 4 does kind of something like that. 1 goes something like this. 2 is just a big old mess of points. We love that it doesn't have a pattern. So which scatter plot? The scatter plot in 2. The residuals. Do not have a pattern. And not having a pattern, like I said, is a good thing. ERN. Okay. Moving on to exercise 4, last one. So the residual plot from 2 different sets of bivariate data are graphed below. Explain using evidence from graphs A and B which graph indicates that the model is a good fit. So good fit, we need this to not have a pattern, so no pattern. Which one doesn't have a pattern? That would be graph A. Graph A, it does not have a pattern. We could say that graph B would have been a poor model because the residual plot has a pattern. And I guess I shouldn't say it. We should say the residual plot. Does not have a pattern. Oh my goodness, what a mess my answer is here. Hang on. Okay, I fixed this. I was clearly talking faster than I was writing. So which is a good fit? Graph A is a good fit because the residual plot does not have a pattern.